Our last unit of the school year is all about spheres, surface area and volume, and this is the final three-dimensional figure of our study of three-dimensional figures. We've done prisms and pyramids, cylinders and cones, and now we're going to take a look at spheres, which are essentially balls, basketballs, baseballs, tennis balls, anything round like this. So, definition, and there are a set of guided notes for those kids who were in class. We had these guided notes where you could just fill in the blanks. I thought it'd make it a little bit easier because our terminology is slightly different on this one. So first of all, a sphere is the set of all points in space equidistant from a given point called the center. Kind of like the definition of a circle. Circle was the set of all points equidistant in a plane from a point called the center. Well, a sphere, they're equidistant in all directions, three-dimensional space. A radius is a segment that has one endpoint at the center and the other endpoint on the sphere. So that would be considered a radius. This one would be considered a radius, going from the center to a point on the sphere. All of those are radii. A diameter is the segment that passes through the center and has endpoints on the sphere. So it passes through the center. So both endpoints are on the sphere, and it has to go through the center. There's an infinite number of diameters, an infinite number of radii in a sphere. When a plane and a sphere intersect, this is like a cross section, and that plane cuts through in more than one point, then that intersection is a circle. You can see that cross section is going to be a circle. As that plane moves down, as it comes down, the circles are going to get bigger and bigger and bigger until it meets it right smack in or goes through the center of the circle. I didn't make that line go through the center. But until the plane goes through the center of the circle. And when that plane passes through the center of your sphere, that circle that it makes is called a great circle. The distance around, or the circumference of that great circle, circumference of this circle, is exactly the same as the circumference of the sphere. If that plane would continue to move down, then the circles would get smaller and smaller. Since the great circle goes through the center of the sphere, then it divides that sphere into hemispheres, exactly two hemispheres, two parts, two equal parts. Like there are two hemispheres in our globe, on our Earth. The great circle divides the sphere into two hemispheres. So we're going to talk about surface area. I can't really talk about lateral area because everything's lateral area on a sphere. It's just one continuous side. So we're just going to talk about surface area. Greek mathematician Archimedes found through a lot of experimentation that the surface area of a sphere is the same as the lateral area of a cylinder, having the same radius as in the picture, and a height, talking about the height of the cylinder, is the length of the diameter of the sphere. Diameter of the sphere would be 2 pi or 2r. The height of the cylinder is 2r. So they have a little matching. Same radius and dimension across. Here's the diameter going up and down, is exactly the same as this one. Lateral surface of a cylinder is found by taking the distance around the circle times the height, and the height in our case is 2r. So I put that in. 2 times 2 is 4. R times R is R squared. And so we end up with our formula for surface area of a sphere. 4 pi R squared. Something you might want to notice here, and it shows you in the picture of the baseball. Pi R squared is the area of a circle. So what it's saying is if I take that baseball apart and I look at it, I have a circle on the top, I have a circle on the bottom, I have a circle on the right and the left. Essentially the lateral area is 4 of those. And this little space in here, well, it makes up for this space out here that doesn't quite fill in the circle. So the surface area of a sphere can be found by taking 4 pi r squared. 4 pi r squared. Whoops, it's not writing. SA equals 4 pi r squared. 4 circle areas. Okay, keep that in mind, is what that means. 4 circle areas. So, we have a tennis ball. The diameter of the tennis ball is 68 millimeters. Diameter is the distance across. We want to know the surface area. Well, if the diameter is 68, that means the radius is half of that, or 34. So the surface area is 4 pi 34 squared. This is definitely a calculator problem. So 34 squared times 4 is 4,624 pi millimeters squared. I'm going to leave it in terms of pi. If you take it times pi in your calculator, you will get a decimal number. Let's do one more. Here's a soccer ball. It has a diameter of 21 centimeters. Notice the word is diameter. That means the radius is half of that, or 10.5. So what's the surface area? Well, it's 4 pi radius squared. 10.5 squared times 4. Make sure you square it before you take it times 4. That's 441 pi centimeters squared. And again, if you want a decimal, just take the 441 times pi. Pretty straightforward, isn't it? So let's change it up a little bit. Okay, and again, here's our next example. Remember, surface area, oops, sorry about it being so large, is 4 pi r squareds. Okay, careful, read what it says. It says we have a grapefruit. The grapefruit has a circumference. That means if I'm looking at my grapefruit, the distance around the grapefruit is 14 centimeters. We want the surface area. To calculate the surface area, we need the radius. Well, look at the picture I drew. I have a circle with a circumference of 14. Grab your formula sheet. How do you find the circumference of a circle? You should see pi times diameter or 2 pi r. Aha! One of them has an r in there. We can find it. 14 is the circumference. 2 pi r is what that equals. I want r, so I'm going to divide both sides by 2 pi. The 2's cancel, the pi's cancel. 14 divided by 2 is 7, or you can think of it as 2 into 2 goes once, 2 into 14 goes 7 times. So my radius, even though it looks kind of weird, is 7 over pi. I'm going to leave it like that. I can punch in a little bit, okay? I can punch in a little bit. So here we go. Let's plug it in. 4 times pi times that radius squared. Don't let that pi and the square get you a little worried. It'll work out just fine. So that's 4 times pi times 7 is 49. Pi times pi is pi squared. Now remember, each of those, that 4 pi, those are over 1. So I have 4 times pi times 49 over pi squared. I could punch all of that in the calculator. I'm going to do a little canceling first. I can cancel out a pi out of each one of these. And then I will have 4 times 49 in my numerator over pi in my diameter, or in my denominator. And this time, I think we're going to get a decimal approximation because that looks really strange. So let's just type everything in. 4 times 49 divided by pi. Where's my pi button? There it is. I get approximately 62.4 centimeters squared because we're dealing with area. Use the formula, keeping in mind that sometimes you might have to solve for something that's missing. All right, we've done surface area. We have done not lateral. The one thing we're missing is volume. I'm going to let you play the video on your own for where this volume of a sphere comes from. I'll be playing it in class. It just kind of shows you how the formula comes about. The formula for volume of a sphere we're going to use is 4/3 pi r cubed. If you think back to pyramids and cones, they were 1/3. Pyramid was 1/3 that of a prism. A cone was 1/3 that of a cylinder. So notice the 4 up here and the 4 here. So a sphere is 4/3 pi r cubed. Cubed because we're dealing with cubic units. Let's just go ahead and use this. All right, let's use it. So we want volume. Volume is, there we go. My pen didn't want to work. 4/3 pi radius cubed. So that's 4 to the 3rd power. On your calculators, you should see this little button that means raised to the power. So whenever you want to do 4 cubed, you can either do 4 times 4 times 4, or you can do 4 caret 3. And then hit the enter button and it will give you exactly the same number. All right, so I have 4 to the 3rd times 4, which is 4 to the 4th, divided by 3, It's going to be 83.3 pi centimeters cubed. And again, you can leave it in terms of pi. If you take that answer times pi in your calculator, you will get 268.1 centimeters cubed. And I don't care if you leave your answers in terms of pi or get decimals. One last example, same formula. This one gives us the volume, and it asks us to find the radius. Same formula, only it says the volume is 288 pi inches cubed, and it wants the radius. So plug in what you know into the formula, and let's undo. We're solving for r, so we're going to undo this equation in a sense. To get rid of multiplication by 4/3, remember we're going to multiply times the reciprocal. The 3's cancel out, the 4's cancel out. And I'm just going to do this step by step because I don't want to lose anybody. So let me take the 288 times 3. That turns into 864. And I could leave it over 4. When I divide by 4, this actually comes out even. So that's kind of nice. 216 pi equals pi r cubed. I'm solving for r, so I need to get rid of multiplication by pi. So let's divide both sides by pi. Pi's cancel out here and here. So that takes us to 216 equals r to the 3rd. And now I need to get rid of that cube. So I'm going to take the cube root of both sides. Now, different calculators work different ways. I'm going to tell you that right now. Some of you will have to type the number that goes under the radical first. Some of you will type it last. I'm checking mine to see which way I need to type it. Okay. On my calculators, you will see a button that looks like this. To type the cube root of 216, what we type on my calculators, I type in the 3, then this button. So it's telling the calculator that my 3 goes where the x is, and then I type the 216 and hit enter. What we get is 6 for the answer. The way you check it, where you check your answer, if 6 is my answer, then that means 6 times 6 times 6 should equal 216, and it does. All right, that's the end of our notes on spheres. The assignment will be posted Monday. I'm going to go ahead and post the notes for those of you who are not in town.